Okay. See here in a deep drawing process, what is deep drawing? Production of cup shaped, box shaped, or any complicated curved parts like automobile bodies or beverage cans, 7-Up, Pepsi can, similar kind of complicated curved shapes can be produced by deep drawing process. So there is a difference between deep drawing and wire and bar drawing. Wire and bar drawing are similar to extrusion, where we pull the material through a die opening, but deep drawing is a slightly different process where we produce complicated or complex curved shape or hollow shaped parts by applying a force. As you can see here, the punch, as it moves downwards, what happens? The blank, which has a diameter B, it will undergo plastic deformation and the material will get squeezed between the punch and die, and finally you can produce a can-shaped product, a hollow cylinder, or similar kind of products, cup-shaped product. You can produce a cup. A cup-shaped product can be produced, or a box-shaped product can be produced. This process, we call it as deep drawing process. As you can see here, the first figure represents the drawing operation before the punch starts moving. You can see here the diameter of punch is dp, diameter of the blank, the work material, is db. It is the blank or the work material, and there is a clearance between the punch and the die. That clearance is represented as c, and the force applied for drawing is F. So as punch moves downwards, in second figure you can see the material will get squeezed in the clearance area. The whole force or stress will be focused in the clearance between the punch and the die. The material will get deformed and you will get a shape like this, a cup shape or a similar shape. This process, we call it as a deep drawing process. So what are the things required for deep drawing? What are the requirements for deep drawing? This thing we are going to study now. Now remember, the starting material blank is having diameter dB, and the final diameter becomes dP, diameter of the punch. Inner diameter is the diameter of the punch, and you can produce cups, cans, automobile parts, etc. using deep drawing process. Now, can we select the clearance similar to shearing operation? Can we select similar to blanking and punching? No, here the clearance, minimum clearance required is 1.1 times thickness of the blank material. So 10% of the thickness of the material or stock thickness. Now there are certain requirements for the blanking operation. What are those requirements? The requirements are termed expressed in terms of drawing ratio, reduction, thickness to diameter ratio. So what is drawing ratio? What is reduction? What is thickness to diameter ratio? We are going to explain now. So drawing ratio, reduction, thickness to. So what requirements need to fulfill so that the drawing is possible? Sometimes you make a punch and die. When you operate, you can find that the material will get sheared. The material will get sheared. It will not undergo drawing process. So what is the requirement of drawing? You are giving a clearance here. The material, if it gets sheared, it will not undergo drawing. It will not produce, you will not be able to produce the shape. So what are the requirements of drawing operation? The requirements are drawing ratio, reduction, thickness to diameter ratio. So what is the drawing ratio here? Diameter of the blank divided by diameter of the punch. Blank is the initial diameter of the material and punch is the final or inner diameter of the cup shaped or any product, box shaped, any product you produce. It is dP is termed as the inner diameter of the workpiece, or you can say the diameter of the punch. So dP is the diameter of the blank and dP is the diameter of the punch. The requirement for drawing operation, if drawing operation need to take place, it must be less than or equal to 2. then only drawing is possible. If the drawing ratio is 3, no, you will not get drawing. The material may get sheared. Now, what is the reduction then? The second criteria is reduction. As I explained, first criteria is drawing ratio less than or equal to 2. Second criteria is reduction. What is reduction? dB minus dP by dV. Difference in diameters of blank and punch by dB must be less than 0.5. If this reduction ratio is less than 0.5, yes, drawing is possible. Greater than 0.5, no, it will not be drawing. Material may get sheared or cutting may take place. So this is second category requirement. Third is thickness to diameter ratio. So if you look at the thickness to diameter ratio, the desirable thickness, blank thickness to diameter of the blank ratio should be greater than 1%. If T by dB is less than 1%, that means 0.01, then the material will have a tendency for wrinkling than a drawing process. So 3 requirements have been shown here: drawing ratio, reduction, thickness to diameter ratio. Drawing ratio should be less than 2, reduction should be less than 0.5, thickness to diameter ratio should be less than 0.5. So this is all, these 3 conditions. Any one of the condition not satisfied, you will not produce a cup, you will not produce a can, you will not produce an automobile body. If any one not satisfied, all 3 will have to be satisfied to prove that the material undergoes drawing operation. So like in any other process, our aim is to study how much is the drawing force required in a drawing operation. So the drawing force required for the drawing operation is pi dP Ts dB or dP minus 0.7. dP is the diameter of punch, T is the thickness of the material, Ts is the tensile strength of the material, dB is the blank diameter, dP is the diameter of the punch, minus 0.7. The 0.7 is a correction factor to account for the friction. Friction need to be considered because there is a friction between the punch and the material and the die. Hence, the friction also need to be considered. A correction factor need to be applied in order to calculate the force, which is pi dP tensile strength times dB or dP minus 0.7. Then we need to find another force, which is called holding force. So the force we studied just now is the maximum force in operation, maximum force required for the drawing operation. Now we have a holding force. What is holding force? So holding pressure after drawing the same force, you need to hold the punch for a certain time to produce or to undergo the deformation. So the holding force is an important factor in a drawing operation. As the holding pressure can be set at a value 0.015 of the yield strength of the sheet metal. This is design value. So this design value multiplied by that portion of the starting area of that blank is to be held by the blank holder. So the holding force in drawing is 0.015 set by the design value, yield strength of the material times pi times dB square, blank diameter square minus dP plus 2.2 T plus 2 RD square. RD is the die corner radius. The die corner small radius will be given for the die. That radius is considered as RD. T is the thickness, dP punch diameter, dB blank diameter, Y is the yield strength. So the holding force FH is the force required to undergo the drawing process. Here F is the maximum amount of the force required for the operation, which is the F is equal to pi dP T, Ts dB over dP minus 0.7. A constant holding force which is required for the operation is calculated using the equation 0.015y dB square minus dP plus. So all these equations are in terms of diameter of the blank and diameter of the punch. So using this equation, we can find the holding and the drawing force. So remember, what is the difference between them? The difference is this F is the maximum or the force required for the drawing operation. FH is the holding force which is required or holding pressure or the force required to undergo the drawing, which is normally 1/3, 1/3 of the maximum force required. Now, drawing radius can be calculated. You have an example here, a drawing operation with the inside diameter of the punch given 75, that is the inside diameter, height 50, starting dB 138, starting diameter is dB 138, thickness T 2.4. So we calculate the three. What are those three important parameters? Drawing ratio, dB over dP, diameter of the blank is 138, diameter of the punch is 75, 1.84. Radius, dB minus reduction ratio, dB minus dP by dB, 45%. T over dB, 1.7%. According to these measures, the drawing operation is feasible because dr less than 2, reduction ratio greater than, correct, reduction ratio is less than 50%, 0.5, reduction is less than 0.5, T by dB is greater than 1%. These three satisfied means drawing is feasible. So this is all about the drawing operation. Now blank size determination for final of the drawn shape to be corrected, starting blank diameter must be right. So dB by solve dB by setting starting sheet metal blank volume. So how you set dB, how you calculate the diameter of the blank. So initial volume of the blank is equal to final volume of the blank. You know what final product volume. You know the final product volume because this is the final design you have, like a cup. You know the final cup volume. That you can equate this final cup volume, for example, to the initial volume, which is pi over 4 d square h, like blank will be cylindrical shape, pi over 4 dB square h. So h, you know the thickness of the blank, you can calculate dB. That diameter need to be used, or the material need to be cut using this diameter. So as I explained before, how you select the diameter of the blank for production of a cup. You use a cup, for example. This cup final volume you have. You can equate this to initial volume. What is the initial material? You see here in this slide, initial, this is the cup. You have the final volume of the cup. This is the cup, you have the final volume. You can calculate. So this is equal to the initial volume of the blank. You know the thickness of the material. dB you don't know. So pi over 4 d square h, or disc shape, you can apply the equation and then you can equate to the final volume and then find the dB, the diameter of the blank. This is how we select diameter of the blank before cutting. Now shapes other than cylindrical, can we produce only cylindrical shapes? No, we can produce a square or rectangular boxes, stepped cups, cones, square or rectangular boxes, stepped cups, cones, cups with spherical rather than flat bases, irregular curved forms like in automobile body panels can be produced. Then as I explained, the cans of the drinks, soft drinks, each of these shapes presents its own unique technical in drawing shapes. Dies for drawing. What are the dies used for drawing process? The dies used are punch and die accommodations are given here. So you can see here, this is the punch and die here, and as punch descends, you can proceed. So once you produce it, this is a punch and die required for a blanking operation, not for a drawing operation. This is for a blanking operation. So So this this material, the stock material will be moved from right to left once the process is over. So in a blanking operation, you will have a punch, you will have a die, and this is the material, and this is the stripper of the material, because if sometimes the material holds the punch, in order to avoid that, you are using a stripper. So as punch moves downwards, it shears the material and the product comes out. So this product, this is the output, this is the product from the operation, and this becomes considered as waste material for blanking operation. So a punch and die arrangement is shown here. And once the once the process is over, the material will be moved from right to left, and the operation will continue. You will have, this is a single punch and a die operation, but each time the material need to be moved from right to left. Now next is a progressive die. You can see several punches are there with different shapes. As the punch moves downwards, different shapes like square, circular, semi-curved shapes. So several shapes can be produced based on the shape of the punch. You can produce several shapes. This is called a progressive die. Then stamping presses. These are the stamping presses used for production. Okay, stamping presses, as you could see here, this is the stamping press which is used for the production process. You have a drive, you have a flywheel, ram moves, and there is a bed, and the material is compressed. So thank you very much for listening. Thank you.